I'm Wally from Black Dot Energy, and this is the maintenance technical training videos for the Barnato Hall solar system. This is video number 2 of the technical training videos, and it's specifically around the solar component of the Barnato Hall plant room. In this video, I'm going to be going through a bit of more technical detail on the solar charging station that basically brings in the renewable energy component into this plant room. In video 1, I already explained that the storage system is 3 tanks that's connected in series, tank 1, 2 and 3, and how the solar system basically charges and brings in that solar heat in tank 1 and 2, and in tank 3 that's heated by the backup redundancy gas heating. The solar charging station, if you've watched the David Webster and the Junction solar videos, what you see here is exactly what you see in the other plant rooms. So we're trying to, with the design of these systems, really standardize the technology and the design philosophy across all the plant rooms. It is an international standard of running the solar systems or configuration of the solar systems, and it's also designed to run 20 years plus given the necessary maintenance cycles. This plant room has now been running with the solar component for over a year, and again the components is exactly the same as what you've seen at David Webster and Junction. The first component being at the back, we've got the plate heat exchanger. The plate heat exchanger basically separates the liquid that flows in the solar panels and the liquid that flows in the tank. So in the solar side of the system, we've got a glycol fluid. Glycol protects the system against freezing, and it also enhances efficiency in terms of energy transfer. So in the plate heat exchanger, you can see at the top, we've got our water that flows to the solar panels. Currently it's just about 35, and the water coming back, it's already 4:30 in the afternoon, is in fact still at 50 degrees. So we've got our loop that heats or brings heat from the solar collectors at the top of the roof. And on the other side, we have the cold water being fed in from the tank. So that's the bottom of tank 1, where the cold water comes in, and the opposite side of the heat exchanger, a 3-way valve. This is exactly the same again as Barnato and Junction, where the system measures the temperatures in the tanks and intelligently decides where's the best point to charge depending on what the temperature of the tanks is. So the 3-way valve basically splits it in a medium temperature and a high temperature, and will load the system accordingly. If you come into the plant room, what are the key things that you need to look at? If you want to know whether the system is functional, the first thing to check is the pressure gauge, because you need 3-bar pressure to be able to cycle the water 4 stories up to the solar collectors. So currently the pressure gauge is showing us 3-bar, which means that the right pressure is there and it's functional. Secondly, what you want to look at is the temperature gauges. So if there's a temperature differential between the solar going to the roof and the solar coming back, you know that the system again is functional, because we've got just about 30 going to the collectors and just over 40 coming back. So there's, even at 4:30, there's still the heat that's being transferred back into the plant room again. Again, then on the other side of the loop, we've got the tanks. So when the temperature gauges are installed on the tanks, you'll be able to see what the temperature is that the system is being loaded at. The next point is then the controller. So if there's no temperature, you know that there's a problem in terms of circulation. As long as there's a display on the controller, you can then know that there's power on the unit. If this is blank, it's either been switched off here at the back, where the main isolator switch is, or it's been tripped in the main DB board. And it's happened before, where the power is stripped in the main DB board and we in fact had no circulation. Currently we are busy upgrading these Technique Alternative loggers or control panels, where we can access it remotely via SIM card, so that we can in fact quantify exactly how much solar energy is contributed into these plant rooms, but it's not yet been done. So it still requires a manual check to see if the system is functional. From a maintenance perspective, if there's complaints of cold water, this is your starting point. Is the system on? Is there pressure? Is there temperature flow? If not, contact the supplier or the contractor to come and do a necessary inspection. There is also maintenance contracts or maintenance cycles where there is preventative checks on the system. Then secondary, to protect the system, when, say for instance in the December holidays, when there's a lot of sun, we can't switch off the sun, and there's no students in the residences, the system in fact can overheat. The way that we protect it again is exactly the same as David Webster and Junction. We've got these membrane expansion vessels. So what will happen if the system goes into stagnation? These membrane expansion vessels have got a rubber membrane, so half is air and half is liquid. If the system goes into stagnation, in other words goes into steam, when it goes into a steam, 1 drop of liquid expands by a factor 1,000. We can in fact accommodate all the liquid, all the glycol that's in the solar collectors can be displaced into these expansion tanks. One of the tricks we do, and we've alluded to that in earlier videos, is this pre-cooling vessel. So this grey vessel is in fact filled with water. It's not insulated because we want it cold. So when the system goes into stagnation and it expands, we in fact expand cold water into these vessels. Hence the membrane lasts a lot longer, and the chances that you've got in the membrane fracturing is really reduced because it's cold water that's coming into the system. The second safety measure is in fact 2 safety pressure valves. The one is on the tank side, so in other words the hot water in the tanks, if that goes over pressure, we've got a safety valve here. So if you come into this plant room and you can in fact see that the floor is stained, it has happened before, this valve will be open and the water would be running out of it. You can easily reset it by just turning the knob. If that has then been reset, please note that these safety valves intended to only open once. So reset it to stop the leaking, but in fact immediately contact the contractor to come and replace that safety valve. It has been discussed in the training with PIMD that we'll in fact have spare components of these safety valves, as those are the immediate failure components somewhere in a box or close by to the station. So if a plumber comes and the valve has failed, that they can easily replace it. The exact same valve is also on the back here on the solar loop. So if the membrane expansion vessels for some other reason fails and the system goes into overpressure, this safety valve at the back here will open up and it will displace the glycol into this drum. And you see there it says glycol overflow spill. The reason for that is 2 reasons. Number one, visually, you'll be able to see if the system went into stagnation because you'll see the green glycol liquid in the tank, and you can contact the contractor to say it had a safety release. If there's glycol in the system, it's impossible that it can circulate because there's air in the system and the hydraulics won't work. Secondary, the glycol is quite expensive. We can then use the same glycol again to recharge the system. So the 3 or the 5 liters or whatever has been discharged, you can use that same glycol then to charge the system. But it's really more for the visual control to see that the system has gone into expansion or the safety valve is open and needs to open up. In summary, visual checks, make sure that there's power to the system, check the pressure and the temperature. If that's all in place and there's other problems, contact the plumbers or the installers so that they can come and check the system. The intention is just to give you a basic overview and understanding of the system. Thank you for watching the video. Also watch our other technical videos, and we trust that this has been very informative to just upskill your technical knowledge on this plant room and how to identify problems and to also communicate it effectively to the contractors when you need to get someone out to site. Thank you very much.